This is number 3, going through antiderivative rules here. The first thing we should always check to see, can we expand? There's too many terms in the denominator. We're forced to have to look at another method. So our next option is U substitution. If we think about U substitution, what can we let our U value be that will allow the remaining x's to go away? And we see the denominator should be a good fit for that, because if we let the entire denominator be our U value, we should produce a derivative with a variable degree that matches the remaining x that we see up top. So we let our U value be 1 plus 4x squared. Our derivative is 8x. We cross multiply. We get dx equals du over 8x. We make our substitutions. The denominator gets replaced with u. Dx gets replaced with du over 8x. And when we do that, we're able to get the x's to cancel out, and we can push that 1/8 out in front. And once we push that 1/8 out in front, then we have integral of 1 over u du, and the integral of 1 over u du becomes natural log absolute value of u plus c, and then replace the u back in terms of absolute value 1 plus 4x squared. Okay, this dx should have been replaced. Dx was replaced with du over 8x. So so just once the x's cancel out, the only thing left are coefficient and u and du. Okay. All right, so answer choice A. All right, number 4. First option, can we expand? Too many terms in the denominator. So we look for U substitution. We look for our U value being, we see a set of parentheses, so let's try that. We'll just let what's inside the parentheses be our U value. 1 plus 4x squared. Derivative is 8x. Cross multiply. Dx equals du over 8x. X's cancel out. Push the 1/8 out in front. But notice how this looks a little bit different than number 3. The rule that we're going to apply is not going to be the same rule. So if you look at number 3, we're left with u to the first power in the denominator. Now this is the only time that you're not going to physically bring that u up to the top. If it's u to the first power in the denominator, we have to go through natural log, because if we force it up to the top and make it u to the -1, we're going to attempt power rule, but it's going to fail. We're going to get u to the 0 over 0. So this is the only time we use a rule different than power rule. If it's a degree that is anything other than u to the first power in the denominator, we're going to have to bring it up to the top and make it go through power rule. Okay. So power rule for u to the -2, we add 1 to the exponent. -2 becomes -1 over -1. We clean this up, multiply, the two negatives become positive. We bring the u back down to the denominator. Plus c, replace the u back in terms of our original variable, in terms of x. Answer choice C. Okay, number 5, we look at the way that this is set up. Too many terms in the denominator. We can't expand this out. We can't bring this up to the top without cleaning up a set of parentheses inside the radical. So we look for maybe U substitution, but it looks like U substitution is not going to be a good fit, because if we let what's inside be our U value, our derivative will produce a -2y, and there's no y in the numerator to match that derivative, so it's not going to work out. But if we look at the degree of the denominator, look at the degree of the denominator. The denominator variable is 2 degrees greater than the numerator, right? You have y squared in the denominator, you have y to the 0 power, or there's no y's up there, so it does fit that criteria. So maybe this is going to be a arc-trig problem. So if we think about arc-trig, the ones dealing with radical in the denominator, that has a constant that is first, that is the positive term, and the variable being the negative term, it'll be the Arcsine rule. So the Arcsine rule says du over square root of a squared minus u squared. So this matches nicely with this form that we have. But if we want to get it to so that we can pick out our a and u value appropriately, we have to get what's inside the radical as both of them set up as parentheses squared. If we can set them up as parentheses squared, we're able to pull what's inside the parentheses as our a and our u values. So 4 is the same thing as 2 squared, and then y squared, we can just rewrite it as parentheses y quantity squared. Our constant is going to be our a value. Our variable is going to be our u value. So u is y, du equals dy. If we make those substitutions back in terms of a and u, this is what we have. And then matches perfectly, no coefficients to keep track of. We can then apply our integral rule. So integral becomes arcsine. U is y in this case. A is 2. So arcsine of y over 2 plus c is our antiderivative. Or you can rewrite arcsine as inverse sine of y over 2 plus c. Answer choice C. Okay. Number 6. So we look at how this problem is set up. Can we expand? Yes. There's only one term in the denominator. I'm going to bring that x safely up to the top. But here's the thing, though. The x is going to come up, but the 2, we're going to leave it in the denominator. Or better yet, let's just push it out in front and still leave it in the denominator, but let's just call it 1/2. If I can kind of isolate the parts that I need to rearrange with the part that is just going to stay until the end of the problem, it just makes things visually easier if I can kind of separate the pieces here. So I'm going to just pull this out as 1/2. I know this 1/2 is going to be part of my answer, but it's not going to be anything that we need to do anything with. It's just going to attach to our antiderivative. So I'm going to deal with that x. That x is going to come up to the top as x to the -1. Now when that x comes up to the top, it's going to force the numerator to be in a set of parentheses as a reminder that this term is going to have to distribute through. So once we distribute through, we add exponents, x to the first power, x to the -1, -1 and +1 will give us 0, so 2 times x to the 0 is just going to be 2. 1x to the -1, that's the same thing as 1 over x. So let's observe and decide which rule we're going to apply. 2, we can apply power rule. 2 becomes 2x. 1 over x becomes natural log of absolute value of x. The 1/2 is still sitting out in front. It's going to have to distribute through the parentheses. We have a plus c involved in our answer. And now we have 1/2 times 2x, which is x. 1/2 times natural log absolute value of x plus c. Answer choice A. All right, number 7. We look for expansion first, but there's not much we can do with the denominator. Let's explore possibility of u substitution. So maybe it has to do with something with the denominator. Let's get a parenthesis to show up. We have a radical there, so rewrite it as parentheses 1 plus sine x quantity to the 1/2. We let what's inside the parentheses be our u value, and we're going to find a way to substitute these pieces here. Our u value is 1 plus sine x. Our derivative is cosine of x. Cross multiply, we get dx equals du over cosine of x. We're going to substitute what I underlined here in red. The parentheses gets replaced with u to the 1/2 in the denominator. Dx gets replaced with du over cosine of x. The cosine of x cancels out nicely. We're going to go ahead and move the u up to the top. You can move the parentheses up to the top earlier if you like. So either way, we're going to have to get it ready for power rule. So once it's set up and ready for power rule, we go through power rule, add 1 to the exponent, divide it by that same exponent value, or that same value that we have up there. And then we have our antiderivative, got the plus c, flip the 1/2 up as 2, and then replace u back in terms of x, and then we can rewrite it as square root, just so that we can make it match one of our answer choices here. So C. Okay, number 8. We do have a rule for secant of u, so this is going to be a u substitution problem. We'll let what's inside that secant expression be our u value. So here's the rule that we're targeting. Integral of secant of u is natural log absolute value of secant u plus tangent u plus c. We let our u value be t over 2. T over 2 is the same thing as 1/2 t. The derivative of 1/2 t is just 1/2. cross multiply, we get dt equals 2 du. We make our substitutions. I'm going to substitute the parentheses. I'll substitute the dt. When I do that, I have secant of u, and then dt gets replaced with 2 du. 2 is a coefficient. I push that out in front. Integral of secant is just natural log absolute value of secant u plus tangent u plus c. And replace so we have our antiderivative. Now we just replace our u back in terms of our original variable, and answer choice E.